Okay, good afternoon, all of you. Am I audible?
Yes, madam.
Okay. Please wait, I will share screen, then we will start lecture. Okay. Good afternoon, all of you. In last lecture, we have started unit number 5, shear force and bending moment diagram. Okay. So in that, we have studied some basic points, how to calculate reactions, types of beams, types of loads, and we have solved some numericals on calculation of reactions. So today we will continue numericals on calculations of reactions. Okay. Now you tell me how many examples we have solved in last lecture.
2.
Two examples.
Yes, ma'am.
Okay. So we will continue next example on reaction calculation. I will draw figures simultaneously. You can also draw. Then we will solve example. Okay. So simply supported beam is given, and on that simply supported beam, uniformly varying load is applied. And after application of uniformly varying load, we have to find out reactions for that simply supported beam. Okay, so this is simply supported beam AB, simply supported beam AB, and one uniformly varying load is applied, and intensity of this load is W. So here uniformly varying load is applied. Okay, and we have to find out reactions for this particular type of beam. Okay. So the span of this beam is L meter. Okay. So here load is applied. So here one vertical reaction RA is there and second vertical reaction RB is there. So for this we have to find out reactions. Okay. So instead of this W, value of load is given. So we will write value. And instead of this span L, the value of load span is given. So I will write values. So total load 60 kilonewton load is applied, uniformly varying load. Okay. And 1 point load, also 1 point load is applied at 2 meter from A support. At 2 meter from A support, and the intensity of this point load is 50 kilonewton. Intensity of this point load is 50 kilonewton. And this point load acts at 2 meter from A support, and remaining span is 4 meter. So total span, which is equal to how much?
6.
Okay, total span is 6 meter. So this is the figure, and for this we have to find out support reactions. Now you tell me what is our first step according to our solution. What is our first step?
Summation FV.
Okay, summation FV. That means we have to take addition of all vertical forces, which is equal to 0. Whenever we will take addition of all vertical forces, at that time we have to use sign conventions. Which sign conventions we will use here?
Upward positive and downward negative.
Okay, so for finding out reactions, first step is summation FV. That means we have to take addition of all vertical forces, which is equal to 0. Whenever we will take addition of all vertical forces, at that time we have to use sign conventions. Upward force we will consider positive, and downward force we will consider negative. So according to this sign convention, now you tell me summation FV. This RA going upward direction and this RB also going upward direction. So it will consider as a positive. So RA plus RB. Okay. Then this 50 kilonewton force going downward direction. So we will consider minus 50. Minus 50. Again this 60 kilonewton force going downward direction. So minus. But this force is uniformly varying force. Okay, this not act at a particular point. So we have to convert into point load. So how to convert into point load? This is the triangular shape and we have to take the area of this triangular shape. So now you tell me area of triangle which is equal to
1/2 into
1/2
length, breadth into height.
1/2 into base into height. 1/2 into base into height. Okay, please do corrections here. The value of the remaining span is 4 meter and total span is 6 meter. Okay, so if uniformly varying load is given, at that time first we have to convert into point load. So how to convert? By taking area of this shape. So this is triangular shape and area of this triangular shape is 1/2 into base into height. So base is 2 meter plus 4 meter, that is 6 into height. That means load is given and height is 60, which is equal to 0. Okay. So RA plus RB minus 50 minus. You do calculations and tell me 1/2 into 6 into 60, which is equal to how much?
180.
180, which is equal to 0. Now we will shift this 50 and 180 to right side. Therefore, RA plus RB, which is equal to 50 plus 180. 50 plus 180. 50 plus 180. So RA plus RB, which is equal to how much?
230.
230.
230 kilonewton. So this is our equation 1. After that, next equation. What is our next equation? Which equation? Second equation.
Summation of
Summation movement at any point which is equal to 0. So we will apply this second equation. Okay. So we will take movement at A point. So second equation is summation movement at A, which is equal to 0. Okay. So whenever we will find movement for reaction calculation, at that time sign conventions, if movement clockwise, then we will consider positive. If movement anti-clockwise, we will consider negative. Okay. So negative. Okay. Now we will take movement from this B point to A point. So this RB creates clockwise or anti-clockwise movement towards A point?
Anti-clockwise.
Anti-clockwise. If movement is anti-clockwise, then sign convention is
Minus.
minus. So minus RB into span. Movement means force into perpendicular distance. So force is RB and perpendicular distance is 6. Okay, now this force is over. Okay, now we will move towards this 50 kilonewton force. This 50 kilonewton force creates clockwise or anti-clockwise movement towards this A point? Clockwise. So plus 50 into perpendicular distance is 2 meter. Okay, now these two forces are over. Now this 60 kilonewton force is remaining. So first we have to convert this UVL to point load and then it will act its CG. So this creates again clockwise movement. So it will be positive. So this force is, okay, this force which is equal to area of this triangular shape is 1/2 into base is 6 into height is 60. It will act at, okay, it will act at whenever we will take centroid from this side. So it will act 2/3 and whenever we will take centroid from this side. बघा हे लक्षात कसं ठेवायचं, छोट्या साइड कडून ज्यावेळेस आपण सीजी घेतो तेव्हा मोठं डिस्टन्स असतं आणि मोठ्या साइड कडून आपण ज्यावेळेस सीजी घेतो तेव्हा छोटं डिस्टन्स. म्हणजे इथे दोन व्हॅल्यू असतात, एक तर 2/3 किंवा 1/3. ज्यावेळी आपण इथे छोटी साइड आहे, छोट्या साइड कडून सीजी घेतोय म्हणजे किती असणार आहे 2/3 आणि मोठ्या साइड कडून जर सीजी घेत असेल तर तो असतो 1/3. सो वी विल टेक सेंट्रॉइड फ्रॉम दिस ए साइड. सो 2/3 into base, 2/3 into base, and base is 6 meter which is equal to 0. Now we will shift this minus RB into 6 to right side. So 50 into 2 is 100 plus. Now you do calculation for this 1/2 into 6 into 60 into 2/3 into 6 and you tell me value of this whole.
720.
720 which is equal to 6 RB. Okay. So therefore 6 RB which is equal to, therefore 6 RB which is equal to 720 plus 100 is 820. Therefore RB which is equal to 820 divided by 6. Now you calculate and tell me the value of RB which is equal to 136.67 kilonewton. Once we got this value, next we have to put this value in equation 1. Okay, we have to put this value in equation 1. Okay, so that we will get the value of RA. Okay, so next step is put RB in equation 1. In equation 1. So our equation 1 is RA plus RB which is equal to 230. So RA plus the value of RB is 136.67 which is equal to 230. So therefore RA which is equal to 230 minus 136.67. So you calculate and tell me RA which is equal to how much?
93.33.
93.33 is correct answer. 93.33 kilonewton. So this is the reaction at A. Anybody having doubt? Ask me. Otherwise, please write down.
मॅडम हॅरिस लोड मध्ये तर डायरेक्शन तर नाही मॅडम, तुम्ही डायरेक्ट प्लस घेतले मॅडम. कसं मॅडम आता पॉइंट लोड मध्ये डायरेक्शन आहे मॅडम, डाउनवर्ड मध्ये डायरेक्शन असतं मॅडम, ते डायरेक्शन असल्यामुळे आम्ही निगेटिव्ह घेतो मॅडम. परंतु हॅरिस लोड मध्ये कारण काही नाही मॅडम डायरेक्शन वगैरे.
हा, आता जरा फिगर कडे थोडं बघा. जर आपला हा AB बीम असेल आणि जर फिगरचं स्ट्रक्चर, लोडचं स्ट्रक्चर ह्या फॉर्म मध्ये आहे तर तो लोड ऑटोमॅटिकली कुठे ऍक्ट होणार आहे तुमचा? बीम वरतीच ऍक्ट होणार आहे ना. का बीम वरती आहे तुमच्या, वरच्या साईडला आहे का बीम? बीम कुठे आहे आपला? डाऊनवर्ड डिरेक्शनला. आणि त्या बीम वरती लोड अप्लाय केलेला आहे म्हणजे तो ऑटोमॅटिक कुठल्या डायरेक्शनला होतोय? डाऊनवर्ड डिरेक्शनला ऍक्ट होतोय. हे थोडं अंडरस्टँडिंगचा पार्ट आहे केकन.
ओके मॅडम.
Okay, if your writing is over, shall I take next problem?
1 minute, ma'am.
Okay, let me know after your writing is over.
Yes, ma'am.
Okay, so we will take next example. I will give example to you. You try to solve. If you are unable, then I will give solution. Okay, so here one cantilever beam is given. On that, one moment is applied 50 kilonewton meter. One uniformly distributed load is applied 30 kilonewton per meter, and one point load is applied 10 kilonewton. Okay, so I will solve this because of here fixed support is there, and due to this fixed support, movement will be generated at A support. So I will give solution. Okay, so according to our first step is summation vertical forces which is equal to 0. At that time, upward forces we will consider positive, downward forces we will consider negative. So this 10 kilonewton, okay, first we will start from this A point. So this RA force going upward direction, okay, you observe here, RA going upward direction, so it will consider as a positive. So RA. Then this 10 kilonewton force going downward direction, so minus 10. After that, this 30 kilonewton UDL going downward direction, so again it will 30. But we have to convert this UDL to point load, so 30 into 9. Now you tell me this 50 kilonewton meter we will consider in this summation FP equation or not?
No,
No.
ma'am. No, ma'am.
No. Why we will not consider this?
Couple, madam.
Yes,
Couple.
because of this is the movement is given. This is not force, this is movement. So we will not consider, which is equal to 0. So RA, which is equal to plus 10 plus 30 into 9 is 270. So RA, which is equal to 280 kilonewton. RA, which is equal to 280 kilonewton. Okay. And one, due to this fixed support, here movement will be there. Here movement will be there, and this is called as MA, movement at A point. So our second equation summation movement at any point. So we will consider at a point, summation movement at A, which is equal to 0. Suppose this is our A point and this is our B point. So whenever we will calculate movements for reactions, clockwise movement positive and anti-clockwise movement negative. Okay. So we will take movement at A and we will start from this B point. So this 10 kilonewton force creates clockwise or anti-clockwise movement?
Clockwise.
Clockwise. So 10 into perpendicular distance is
9.
9 meter. Okay. After that, this 30 kilonewton force creates clockwise or anti-clockwise movement?
Clockwise.
Clockwise. So plus, okay. First, we have to convert this UDL to point load. So 30 into 9. This is UDL to point load. And it will act as CG. So 9 by 2. Okay.
2.
After that, we will move towards next point. That is our 50 kilonewton meter. It creates anti-clockwise. Okay.
Minus
Anti-clockwise. So minus 50. Here 2 meter distance is given. Okay. So we will multiply by 2 meter or not?
No.
No, not because of moment is already given, so which is equal to 0. No, MA is remaining. And this MA creates again anti-clockwise movements. So minus MA, which is equal to 0. We will shift this minus MA to right side. So 10 into 9 is 90 plus 2 ones are 2, 2 ones are 2, 2 5s are 10. So 15 into 9 into 9. How much?
First this 135.
135 minus 50, which is
50.
equal to MA. So therefore, movement at A point, which is equal to how much?
175. 175. 175.
175.
मॅम ते
Yes, ma'am.
15 into 9 into 9 पाहिलं. Into 9 ने मल्टिप्लाय केलं नाही.
Where?
1215 येते मॅम तिथं 135 च्या ऐवजी
1215 येते.
125 येते मॅम याने.
Okay. Now you tell me. 90 plus how much?
1215
1215.
1215 and then minus 50, na?
हो मॅम.
Okay, minus 50. So now you do calculations. 90 plus 1215 minus 50, which is equal to
1255.
1255.
1255 kilonewton meter. So this is movement. So if cantilever beam is given, okay, so at fixed support, one movement will be there, and this movement which is equal to 1255 kilonewton meter, and only one reaction is there at fixed support. At free support, there is no any reaction and there is no any movement. So if question is given likewise, then you have to follow these steps. So please write down. So we will solve next numerical.
हॅलो मॅडम.
हा बोला.
जेव्हा युडीएल दिलेले असते मॅडम, युडीएल चे 30x9 हे केले की मॅडम ते पॉइंट लोड मध्ये कन्वर्ट होते ना मॅडम.
हो
डिस्टन्स इंटू युडीएल केले की मॅडम ते स्पॅन किती मॅडम 9 मीटर आहे मॅडम आता. आता ते पॉइंट लोड मध्ये कन्वर्ट केले की मॅडम ते किती 4.5 मध्ये स्पॅनचे पॉइंट लोड होते ना, ऍक्ट होते ना मॅडम. परत ते एमए मध्ये असं हे केलं की चालत नाही का मॅडम?
नाही चालत बघा, आन्सर सेम येत नाही शक्यतो, चेक करून बघा. पण ही अशीच मेथड बरोबर आहे, हीच मेथड फॉलो करा.
मी तसं केलं मॅडम, तसं केलं की 175 आन्सर येते मॅडम.
हा ते चुकतंय आन्सर, हीच मेथड फॉलो करा.
ठीक आहे मॅडम.
Okay, your writing is over. Shall I take next problem? Yes, or you want time?
Yes.
Yes.
Okay, shall I take next problem now?
Yes.
Okay. Okay, we will take last problem on this reaction calculation, and then we will move towards shear force and bending moment. So please draw figure. We will solve this last numerical on reaction calculations. Which type of beam is given here?
Overhanging.
Overhanging beam is given. This overhanging distance is 2 meter and this overhanging distance is 3 meter and remaining distance is 7 meter. And the intensity of UDL is 20 kilonewton per meter. 20 kilonewton per meter. So this is overhanging beam is given, and on that beam one uniformly distributed load is applied, and the intensity of this uniformly distributed load is 20 kilonewton per meter. And for this we have to find out reactions, that is RA and RB. Okay, our regular procedure we have to follow here. So our first step is reaction. First step is we have to take addition of all vertical forces, that is summation FB, which is equal to 0. So for this downward force we will consider negative, upward force we will consider positive. So according to these sign conventions, this RA and RB going upward direction, so we will consider it as a positive. So RA plus RB, then this 20 kilonewton force going downward direction, so minus 20. This is uniformly distributed load, so we have to convert into point load. So 20 into span is how much? 12 meter. 12, which is equal to 0. Now we will shift this minus 20 into 12 to the right side. So RA plus RB, which is equal to 20 into 12. So RA plus RB, which is equal to 240 kilonewton. This is our equation 1. After that, we will apply second equation. Second equation is summation moment at any point. So we will take at a point A, which is equal to 0. For these sign conventions, clockwise movement positive, anti-clockwise movement negative. Okay. So we will start from this B point. So this B, RB creates anti-clockwise movement. Okay, and RB is force and perpendicular distance is how much?
7.
7. So minus RB into 7. After that, this 20 kilonewton force creates clockwise movement. So plus 20 into perpendicular distance is how much here? So first we have to convert this 20 into point load. So from this A point to remaining distance is 10 meter. So our load is 20 into 10 and after that it will act as is CG. Okay. So now this load is over. Okay, unmute yourself. Okay, so 20 into 10 is UDL to point load and after that it will act its CG, that is 10 by 2. And now one force is remaining. This 20 kilonewton left of this A side. So this 20 kilonewton creates clockwise or anti-clockwise movement?
Clockwise.
No, you observe here. This 20 kilonewton creates anti-clockwise movement. So minus 20 into span is from this to this 2 meter only. Okay, and it will act 2 by 2, which is equal to 0. We will shift this RB into 7 to right side. So 2 1s are 2, 2 5s are 10. 20 into 10 into 5, which is equal to how much?
1000.
1000 minus these 2 1s are 2, 2 1s are 2. 20 into 2 is 40, which is equal to 7 RB. 7 RB. Therefore, RB, which is equal to 1000 minus 40 is 960, right?
Yes, ma'am.
960 divided by 7. So therefore, RB, which is equal to RB, which is equal to
137.4.
137.14 kilonewton. So this is the RB. Now we will put the value of this RB in equation 1 and we will find out the value of RB. So we will put this value of RB in equation 1. So for this our equation 1 is so that next is put RB in equation 1. So RA plus RB, which is equal to 240. So RA plus 137.14, which is equal to 240. Therefore, RA, which is equal to 240 minus 137.14. So RA, which is equal to how much?
102.86.
102.86 kilonewton. 86 kilonewton. So this is the reaction at A point. Anybody having any difficulty or any doubt? Ask me. Otherwise, please write down fast.
मॅम ते मुवमेंटचं सांगा ना.
अजून एकदा सांगा मॅडम ते मोमेंट.
ठीक आहे, मी अजून एकदा सांगते. बघा आता इथे काय आहे, ओव्हरहँगिंग बीम दिलेले आहे. ओव्हरहँगिंग ए पॉइंट पासून 2 मीटर ओव्हरहँग आहे आणि बी पॉइंट पासून 3 मीटर ओव्हरहँग. तर आपण काय करतोय, ए पॉइंट भोवती मुवमेंट घेतोय. ठीक आहे, मग फर्स्ट आपण हा आरबी कन्सिडर केला. आरबी काय होतोय, अँटी क्लॉकवाईज मुवमेंट करतोय आणि परपेंडिक्युलर डिस्टन्स किती आहे, 7 मीटर. ह्याच्यात तर कोणाला काही डाऊट नसेल. आता बघा आपल्याला काय करायचं की ए पॉइंटला मुवमेंट घ्यायची, बरोबर आहे. मग ए पॉइंटच्या राईट साइडला कुठला फोर्स आहे, तर 20 किलो न्यूटन आहे. आणि तो 20 किलो न्यूटन फोर्स किती स्पॅन वरती ऍक्ट झालेला आहे, ए पासून राईट साइड. ए पासून राईट साइडला तो 10 मीटर वर ऍक्ट झालेला आहे. म्हणजे काय करावं लागेल आपल्याला, 20 इंटू 10 आणि मग तो कुठे ऍक्ट होणार, 10/2 ला. आता लक्षात आलं का हे राईट साइडची मुवमेंट कशी घेतली आहे ते.
येस मॅम.
आता बघा, आता
टोटल घेतलं
नाही ना, टोटल कसं
टोटल स्पॅन घेतलं,
टोटल स्पॅन घेतला तर तसं तुमची मुवमेंटच येणार नाही ना. टोटल स्पॅन कसं कन्सिडर करणार आणि कुठल्या पॉइंटला ऍक्ट करणार मग तुम्ही तो. आपल्याला पर्टिक्युलर एका पॉइंटला ऍक्ट करायचा आहे ना तो. जर आपण टोटल घेतलं 20 × 12 × 12/2 मग इथे पॉइंटच नाही, हा ओव्हरहँगिंग ऍक्ट होतोय. ओव्हरहँगिंगला सपोर्ट आहे का इथं? विदाउट सपोर्ट हा फ्री आहे. फ्री सपोर्टला आपण मुवमेंट काढू शकतो का? नाही काढू शकत. म्हणून आपल्याला काय करायचंय की जिथे सपोर्ट दिलेला आहे त्या सपोर्टच्या भोवती मुवमेंट काढायची. मग सपोर्ट कुठे आहे आपला? ए पॉइंटला. मग ए पॉइंटच्या राईट साईडला पण फोर्स आहे आणि ए पॉइंटच्या लेफ्ट साईडला पण फोर्स आहे. तर पहिले आपण राईट साईडची मुवमेंट घेतली. मग ए पॉइंट पासून राईट साईडला फोर्स किती आहे? 20. तो युडीएल आहे म्हणून त्याला त्याच्या स्पॅननी मल्टिप्लाय करावं लागेल. 20 × स्पॅन इज 10 and it will act at 10/2. हा फोर्स संपला. आता आपल्याला ए पॉइंटच्या लेफ्ट साईडला चेक करायचे की फोर्स आहे का? तर आहे. तर त्या फोर्सची इंटेन्सिटी किती आहे? 20 kN/m आहे. बरोबर आहे. आणि त्याचा स्पॅन किती मीटर आहे? 2 मीटर. सो 20 × 2 and it will act at 2/2. अशी मुवमेंट फाइंड आउट करायची. जर आपण 12 मीटर कन्सिडर केलं तर इथे फ्री सपोर्ट आहे. फ्री सपोर्टला मुवमेंट कधीच ऍक्ट होत नसते. त्यामुळे आपल्याला एकतर ए ला मुवमेंट घ्यावी लागेल किंवा एकतर बी ला मुवमेंट घ्यावी लागेल. आता आलंय का लक्षात?
Yes.
Okay, so please write down. Then we will move towards next point.
मॅडम जर मुवमेंट ऍट बी ला जर घेतलं तर मग लास्टला 20 × 3 × 3/2 असे ना.
येस. मग त्यावेळी असं येणार बघा. जर आपण मुवमेंट बी पॉइंटला घेतली तर आपलं कसं असणार आहे बघा. मुवमेंट ऍट बी तर हा 20 kN अँटी क्लॉकवाईज मुवमेंट करतोय. बरोबर आहे. सो -20 × डिस्टन्स इज हाऊ मच? 7 + 2
9
into 9/2 and this 20 creates clockwise movement towards this B point. So plus 20 × 3, this is load, into 3/2 and this RA creates anti-clockwise movement. No, so RA creates clockwise movement. Okay, this RA creates clockwise. So plus RA into perpendicular distance is from this A to B 7 meter, which is equal to 0. Now you solve this and check answer which is equal to how much? RA which is equal to how much? किती येते व्हॅल्यू? You shift this -20 × 9 × 9/2 to right side. So it will plus 20 × 9 × 9/2. And this plus 20 × 3 × 3/2 will
तेवढंच येते म्हणा.
RA 102.86 येतोय का?
हा तेवढंच येते.
हा म्हणजे तुम्ही मुवमेंट राईट साइड कडून ए पॉइंट कडून घेतली काय किंवा बी पॉइंट कडून घेतली काय, आन्सर आपलं सेमच येणार. पण फक्त काय होतं, थोड्या व्हॅल्यू चेंज होतात ज्यावेळी आपण मुवमेंट कन्सिडर करणार आहे त्यावेळी. आलंय का लक्षात आता मुवमेंटचं कॅल्क्युलेशन?
येस मॅडम.
Okay. If your writing is over, shall I move towards next point?
Yes, ma'am.
Okay. So now reaction calculation numericals are over. So we will move towards our actual syllabus. That is what is meant by shear force diagram and what is meant by bending moment diagram. And after that we will solve numericals on shear force diagram and bending moment diagrams. Okay. So for this, I will share new screen. Okay, screen is visible.
Yes, ma'am.
Which slide is visible to you? Shear force diagram slide is visible.
Yes, madam.
Okay. Wait, I will make slideshow. Now it is visible.
Shear force diagram, sir.
Okay. So please write down next point, shear force diagram. Next point, shear force diagram. Next point is shear force diagram. Next point, please write down this shear force diagram. Shear force diagram. That means SFD. Okay. Before considering the shear force diagram, we will first see what is meant by shear force, and then we will move towards the shear force diagram. So first, in that first point, please write down shear force. In that, write down first point, shear force. Shear force, that is SF. Shear force. First, we will see what is meant by shear force, and then we will move towards what is meant by shear force diagram. Okay. First, you write down definition, then I will explain. So please write down. A shear force is defined as. A shear force is defined as. Shear force is defined as. Shear force is defined as the algebraic sum of all the vertical forces, algebraic sum of all the vertical forces, Swarpaviram, either to the left, or to the right hand side of the section, or to the right hand side of the section, Okay, so this is the definition of shear force. Okay, now I will explain. Suppose we have taken this is simply supported beam. Okay, and on that beam, one central point load is applied W. So after application of load, two reactions will be generated, RA and RB. Now you tell me, RA which is equal to how much and RB which is equal to how much?
W by 2.
W by 2. Okay, so due to this W, two reactions will be generated. That means this total load will carry by one support, half of one support and half of another support. म्हणजे काय होणार आहे? टोटल लोडच्या हाफ लोड काय करणार आहे? एक सपोर्ट घेणार आहे आणि रिमेनिंग हाफ लोड कोण घेणार आहे? तुमचा सेकंड सपोर्ट घेणार. So due to this W, RA which is equal to W by 2 and RB which is equal to W by 2. So now we will see what is meant by shear force. Okay, so shear force means we have to take addition of all vertical forces, only vertical forces. Okay, so for that, suppose I have taken section here. XX section. Okay, XX section. So we have to take addition of vertical forces, but either from left side or either from right side. म्हणजे काय करायचं आपल्याला इथे की वर्टिकल फोर्सेसचे ऍडिशन करायचे, पण एक तर लेफ्ट साइड कडून किंवा एक तर राइट साइड कडून, आणि जी व्हॅल्यू मिळते त्याला आपण काय म्हणणार आहे? शियर फोर्स. लक्षात आलंय? शियर फोर्स इज नथिंग बट वी हॅव टू टेक ऍडिशन ऑफ ऑल वर्टिकल फोर्सेस आयदर फ्रॉम लेफ्ट साइड or either from right side. Okay, in detail we will see in examples, but just you have to remember shear force means addition of all vertical forces either from left side or either from right side of the section. This is called as shear force. Okay, after that now we will see next definition, shear force diagram. So please write down next point, shear force diagram. Next point is shear force diagram. Next point is shear force diagram. This is second point, shear force diagram. Okay, write down definition first, then I will explain. It is graph connecting. It is graph connecting. It is graph connecting. It is graph connecting shear forces. Shear forces. Shear forces. Shear forces at various locations on the beam. at various locations on the beam. Various locations on the beam. So simply shear force diagram nothing but it is a graph connecting various shear force at various locations. Okay. Suppose this is simply supported beam AB and we have calculated shear force at A, that is W by 2. Shear force at B, W by 2. And we have calculated shear force at C point. Shear force at C. So after calculating, we have to draw graph between various locations. म्हणजे A point ला काय shear force ची व्हॅल्यू असेल, C point ला shear force ची व्हॅल्यू काय असेल आणि B point ला shear force ची व्हॅल्यू काय असेल. तर दोन पॉइंट मधले जे काही shear force ची व्हॅल्यू आहे ती आपण जी ग्राफनी कनेक्ट करतो त्याला आपण काय म्हणतोय shear force diagram. Okay, this is called as shear force diagram. Now third point is most important point related to sign convention. So first you write down this point, then I will tell you how to remember. Okay. So a shear force, write down next point. A shear force which tends to rotate the beam in clockwise direction is positive and vice versa. Now the sign conventions are very important for these shear force calculations. Okay, please see carefully. Okay, here one sentence is given. A shear force which tends to rotate the beam in clockwise direction. जर beam हा clockwise direction मध्ये rotate होत असेल तर आपल्याला काय consider करायचं positive. Okay, so first you write down this. Suppose load is applied here and here shear force is applied. So this is suppose RA and here shear force is applied. Now you tell me, this shear force rotate beam in clockwise direction and this RA also rotate to beam in clockwise direction. You observe here, this RA creates clockwise rotation and this shear force also creates clockwise direction. That means if the beam is rotated in clockwise direction, then we will consider this shear force as a positive. म्हणजे आता shear force calculation करताना upward आणि downward चा विचार करायचा आहे का नाहीये, तर ते upward आणि downward, clockwise किंवा anti clockwise हे कशासाठी आहे, फक्त रिएक्शन कॅल्क्युलेशन साठी आहे, त्याचा विचार आपल्याला आता करायचा नाहीये. सो फॉर shear force calculation जर बीम हा clockwise रोटेट होत असेल, म्हणजे बघा हा RA काय करतोय clockwise रोटेशन आणि या shear force मुळे पण काय होतंय clockwise rotation. So our shear force is positive shear force. Okay, here clockwise rotation is there, so positive shear force. And second sign convention I will draw here. Suppose this is beam. Here RB load is there and here shear force is applied. Here shear force. Now you tell me this shear force creates which rotation?
Anti-clockwise.
हा shear force मुळे कुठलं रोटेशन क्रिएट होतंय अँटी क्लॉकवाइज आणि हा आरबी पण कुठलं रोटेशन क्रिएट करतोय अँटी क्लॉकवाइज. सो इफ rotation of beam is anti-clockwise, then shear force is negative shear force. आता लक्षात आले shear force चे कॅल्क्युलेशन्स कशावर डिपेंड असणार आहेत, बीमचं रोटेशन हे क्लॉकवाइज होतंय की अँटी क्लॉकवाइज होतंय. सपोज हा बीम आहे आणि हा बीम जर असा रोटेट होत असेल म्हणजे रोटेशन काय आहे तुमचं क्लॉकवाइज आहे, ठीक आहे, आणि तोच बीम जर अशा टाइपनी रोटेट होत असेल तर ते रोटेशन काय असणार आहे तुमचं अँटी क्लॉकवाइज. म्हणजे shear force when we are going to calculate shear force, at that time sign conventions are depends on rotation of beam. Beam will rotate clockwise, we will consider positive, and beam will rotate anti-clockwise, we will consider negative. Anybody having doubt in sign convention for shear force calculation?
No, ma'am.
Okay.
No, ma'am.
Then we will move towards next point, bending moment diagram. Okay, bending moment diagram slide is visible.
No.
No, ma'am.
Wait, I will share once again. Now?
Yes, ma'am.
Yeah.
Okay. So please write down next point, bending moment diagram. Next point is bending moment diagram. Next point is bending moment diagram. Bending moment diagram. Next point is bending moment diagram. Bending moment diagram. BMD. So first we will see what is meant by bending moment. First we will see what is meant by bending moment, and then we will see bending moment diagram. So bending moment means BM. BM. Okay, please write down definition. A bending moment is defined as bending moment is defined as the algebraic sum of the moments of all the forces, algebraic sum of the moments of all the forces either to the left or to the right side of a section, or to the right side of a section. Okay, so suppose this is simply supported beam. Here central point load is applied W. This is A point, this is B point. Here RA reaction is there, here RB reaction is there. Okay, and now we have to find out bending moment, or we have to do calculations for this bending moment. So what is meant by bending moment? So bending moment means we have to take summation of all the moments of all forces. म्हणजे ह्या RA मुळे क्रिएट होणारी मोमेंट, W मुळे क्रिएट होणारी मोमेंट, RB मुळे क्रिएट होणारी मोमेंट. पण suppose we have taken section here, XX section. Okay, so we have to take algebraic sum of all moments due to all forces from this left side or right side. म्हणजे आपण काय करू शकतो, या लेफ्ट साइड कडून मुवमेंट घेऊ शकतो किंवा या राइट साइड कडून मुवमेंट घेऊ शकतो. तर बघा आता इथे मुवमेंट जर आपण सपोज लेफ्ट साइड कडून घेतली, लेफ्ट साइड कडून, तर हा RA फोर्स बीमला अपवर्ड पुश करतोय, म्हणजे काय असणार आहे, पॉझिटिव्ह. सो प्लस द व्हॅल्यू ऑफ RA इज W/2 into perpendicular distance is X. So that much calculation is there. But we have taken movement from this right side. This RB pushes beam to upward. So plus W/2 into, suppose this is total span L. Out of that, this distance is X. So this is L minus X. Okay. And this W force pushes beam to downward direction. So that means minus sign is there. So minus W into W into, suppose this is L by 2 and this distance is L by 2 and we have taken section here. Okay, and here distance, perpendicular distance we have to consider. So bending moment means we have to take algebraic sum of moments of all forces from right side or left side. म्हणजे काय करायचं आपण, जिथे बीम कट करतोय त्या कट केलेल्या बीमच्या लेफ्ट साइड कडून किंवा राईट साइड कडून जे काही नंबर ऑफ फोर्सेस असतील त्या फोर्सेस मुळे क्रिएट होणारी मुवमेंट आपल्याला फाइंड आउट करायची, ते म्हणजे काय असतील आपले बेंडिंग मुवमेंट कॅल्क्युलेशन्स. ओके, प्लीज राइट डाउन नेक्स्ट डेफिनेशन. बेंडिंग मुवमेंट डायग्राम. बेंडिंग मुवमेंट डायग्राम. बेंडिंग मुवमेंट डायग्राम. Bending moment diagram. Okay. Diagram, bending moment diagram is graph connecting. Bending moment diagram is graph connecting bending moments at various locations. Bending moment at various locations. Bending moment at various locations. Bending moment at various locations. सो बेंडिंग मुवमेंट डायग्राम म्हणजे काय असणार आहे, तो एक ग्राफच आहे. तर तो ग्राफ काय कनेक्ट करतो, तर व्हॅरियस लोकेशन्सला. म्हणजे ए पॉइंटला काहीतरी बेंडिंग मुवमेंटची व्हॅल्यू असेल, बी ला काहीतरी असेल, सी ला काहीतरी असेल. तर त्या ए बी सी ला जी काय व्हॅल्यू असेल ती व्हॅल्यू कनेक्ट करतो, म्हणजेच त्या ग्राफला आपण काय म्हणतो, बेंडिंग मुवमेंट डायग्राम. ओके, नाउ इन दिस साइन कन्व्हेन्शन्स इज मोस्ट इम्पॉर्टंट. Please write down sign conventions for BMD. Next point is sign conventions. Sign conventions for BMD. Sign conventions for BMD. Okay. Now, whenever we will calculate bending moment, at that time we have to consider following two sign conventions. Okay, so first one is sagging type of nature. Okay, first one is sagging. If beam is bent sagging, then we will consider positive, and if beam bending or curvature of bending is hogging, then we will consider negative. आता हे लक्षात कसं ठेवायचं बघा, हात वर करून बघा, स्वतःचे हात वर करा. हात वर केल्यावर पॉझिटिव्ह एनर्जी मिळते का निगेटिव्ह एनर्जी मिळते?
पॉझिटिव्ह.
बघा आपले हात वर करून बघा, म्हणजे आपल्याला लक्षात येतं. हात वर करा, स्वतःचे हात फक्त वर करायचे.
निगेटिव्ह
आपल्याला जेवढं शक्य आहे
नेगेटिव्ह मॅडम.
निगेटिव्ह कमी, म्हणजे वर एनर्जी जास्त लागते वर करायला.
आता खाली सोडून बघा बरं असं हात, असं काय होते बघा बरं, जरा हात खाली सोडल्यावर. ज्यावेळी आपण हात वर करतो त्यावेळी आपल्याला फ्रेश वाटतं, म्हणजे पॉझिटिव्ह एनर्जी तयार होते. आणि तेच जर आपण हात खाली सोडले तर आपल्याला असं एकदम कंटाळा आल्यासारखं वाटतं, म्हणजे निगेटिव्ह एनर्जी तयार होते. सो अपवर्ड फोर्स क्रिएट्स पॉझिटिव्ह, that is sagging type of curvature, and downward force creates hogging type of curvature. Please remember, upward force create positive, that is sagging type of curvature, and downward force creates hogging type of curvature, that is negative. So these sign conventions most important. These two are applicable for finding out bending moment. And for shear force, if beam rotate clockwise direction, then positive, and if beam rotate anti-clockwise direction, then negative. जे आपण अपवर्ड आणि डाऊनवर्ड कन्सिडर करत होतो ते कशासाठी आहेत? फक्त रिएक्शन साठी आहेत. ज्यावेळी आपल्याला शिअर फोर्स आणि बेंडिंग मुवमेंट फाइंड आउट करायची त्यावेळी बीमचं रोटेशन क्लॉकवाईज असेल तर पॉझिटिव्ह, आणि बीमचं रोटेशन अँटी क्लॉकवाईज असेल तर निगेटिव्ह. हे दोन साइन कन्व्हेन्शन्स फॉर शिअर फोर्स. आणि बेंडिंग मुवमेंट साठी अपवर्ड फोर्स क्रिएट्स positive energy, that is sagging type of curvature plus, and downward force creates negative energy. Okay, that much sign conventions you have to remember. Now we will solve first numerical on shear force and bending moment diagram. Shall I take?
Yes.
Okay, so please write down first example. SFD and BMD, SFD and BMD, SFD and BMD, SFD and BMD for simple cases, BMD for simple cases, of simply supported beams, of simply supported beams, simply supported beams, simply supported beams. So first we will start from simply supported beam. So in that first we will see first SFD and BMD, SFD and BMD, BMD for simply supported beam, simply supported beam, simply supported beam, simply supported beam with central point load, with central point load. Central point load. Okay, so first we will see SFD and BMD for simply supported beam with central point load. So for this first we will draw figure and then we will solve. So please draw simply supported beam. This is simply supported beam and on that beam one central point load is applied. Okay. So this is simply supported beam AB. And here one central point load is applied W. So this point is C point. Okay. And this span is L by 2 and this is L by 2. So whenever we will add L by 2 plus L by 2 which is equal to L. Okay, so this is the question. For this figure, we have to do calculations of shear force, bending moment, and after calculations, we have to draw shear force diagram and bending moment diagram. So our first step for this, our first step is reaction calculations. First step is reaction calculations. Reaction calculations. So when you will solve problem, at that time first step is compulsory reaction calculation. That's why we have solved some numericals on this reaction calculations. Okay, so first step reaction calculation. In reaction calculation, now you tell me which first step is there. In reaction calculation,
RA plus RB.
summation FB which is equal to 0. Now, whenever we will calculate reactions, at that time, upward force we will consider positive and downward force we will consider negative. Okay, for this summation FV equation. So these RA and RB going upward direction. So we will consider positive. So RA plus RB. Then this W going downward direction, so it minus W, which is equal to 0. Therefore, RA plus RB, which is equal to W. This is our equation first. After this summation FV, next equation for reaction is
Movement at any point.
summation movement at any point. So we will take A, which is equal to 0. In reaction calculation, whenever we will calculate movement, at that time clockwise movement is positive and anti-clockwise movement is negative. So now we will start from this B point. This B creates anti-clockwise movement towards this A point. So minus RB into perpendicular distance is L by 2 plus L by 2, that is L. This W creates clockwise movement towards A point. So plus W into perpendicular distance is how much?
L by 2.
L by 2. Now I will consider this RA point, but perpendicular distance is not there. Force is there. बघा RA फोर्स आहे, पण A पॉइंटला परपेंडिक्युलर डिस्टन्स घेऊ शकतो का आपण इथे काही? नाही घेऊ शकत, म्हणून तो फोर्सच आपण कन्सिडर करत नाही, which is equal to 0. Okay. Now we will shift this minus RB into L to right side. So W L by 2, which is equal to RB into L. So this L and L gets cancelled, and finally we get RB, which is equal to W by 2. So this is the reaction at B point. Once you got the value of RB, you have to put this value in equation 1 and calculate the reaction at A. Now we will put value in equation 1. So next step is put RB in equation 1. So our equation 1 is RA plus RB, which is equal to W. So RA plus W by 2, which is equal to W. RA, which is equal to W minus W by 2. Okay, you have to make same denominator. So we will make cross multiplication. So 2W minus W divided by 2. So RA, which is equal to 2 minus 1 is 1. So W by 2. So reaction at A point, which is equal to W by 2. These are the reactions. So RA, which is equal to W by 2, and RB, which is equal to W by 2. Anybody having doubt in reaction calculation?
No, madam.
Okay. Now our second step, most important step, shear force calculations. Second step is shear force calculations. Second step, shear force calculations. So for this shear force calculations, sign convention, if beam rotate clockwise, we will consider positive. Beam rotate anti-clockwise, we will consider negative. Okay. Now we will start shear force calculation from this A point. From this A point, so we will write here shear force at A. Shear force at A. Shear force at A, which is equal to shear force at A, which is equal to. Okay. So for calculating this, we will consider this beam and we have taken section here. Okay. So whenever we will cut the beam, okay, whenever we will cut the beam, at that time it will automatically fixed. म्हणजे ज्यावेळी आपण बीम कट करतो त्यावेळी तो ऑटोमॅटिकली कुठला सपोर्ट होत असतो? फिक्स्ड सपोर्ट. ओके. बघा आता हा W/2 अपवर्ड डिरेक्शनला जातोय, मग त्याला बॅलन्स करण्यासाठी कुठल्या डिरेक्शनला W/2 द्यावा लागेल? हा W/2
डाउनवर्ड.
अपवर्ड साइडला जातोय, त्याला बॅलन्स करण्यासाठी आपल्याला काय करावं लागेल? W/2 डाउनवर्ड डिरेक्शनला, म्हणजेच हा काय असणार आहे? शियर फोर्स विच इज इक्वल टू W/2. आता बघा हा W कुठल्या टाइपचं रोटेशन क्रिएट करतोय? क्लॉकवाईज. आणि हा शियर फोर्स कुठलं रोटेशन क्रिएट करतोय? क्लॉकवाईज. सो therefore shear force at A which is equal to plus W/2 kilonewton plus W/2 kilonewton. कोणाला ह्याच्यात काही डाऊट आहे? शियर फोर्स ऍट ए ला? ओके, now we will move towards next point, shear force at C. पण बघा C ला आपल्याला 2 वेळा शियर फोर्स कॅल्क्युलेट करायला लागणार आहे. कुठले 2 पॉइंट असतील? कोण सांगते बोलून?
A and C.
ओके, शियर फोर्स बिफोर C म्हणजे बिफोर ऍप्लिकेशन ऑफ W अँड शियर फोर्स आफ्टर ऍप्लिकेशन ऑफ W. म्हणजे आपल्याला इथे शियर फोर्सची व्हॅल्यू काय करावी लागेल? 2 वेळा फाइंड आउट करावी लागेल. ठीक आहे, तर फर्स्ट वी विल कॅल्क्युलेट शियर फोर्स ऍट C बिफोर पॉइंट लोड. बिफोर point load. Okay, we have drawn this figure, but this figure is applicable for C point. The same concept is there. Okay, you observe here at A point only one force is there, only one force, and this force pushes beam to clockwise or rotate beams to clockwise direction. So shear force at A which is equal to plus W/2, we will take as it is, W/2 kilonewton. After that, second point, shear force at C but before W. Shear force at C but before W. Before point load. Before point load. Before point load, and for this figure is likewise. So this is our simply supported beam and before point load. So we have cut the section here. After cutting, this support automatically fixed the support, and here this is A point. At A point W/2 force is there, W/2. So for this balancing, we required opposite W/2, that is downward W/2, and this is nothing but shear force. This is nothing but shear force, and intensity is W/2. So this shear force rotate beam to clockwise direction, and this W/2 also rotate in clockwise direction. That's why shear force at C, but before point load, which is equal to how much? Shear force at C which is equal to plus W/2 kilonewton as it is. After that, next we will find out shear force at C. Shear force at C but after point load. After point load. So for this I will draw figure here after point load. So this is our beam here, W/2 force is applied, and here we will consider this W. Okay, this W, because of we have taken section here after W, no? Okay, now you observe here W/2 is there and total force is W. But for this balancing, how much force is required? बघा इथे टोटल फोर्स W ऍक्ट होतोय आणि त्याच्यातून फक्त W/2 त्याला रेजिस्ट करतोय, म्हणजे कितीची कमतरता होती त्यातून? अजून किती फोर्स द्यावा लागेल आपल्याला त्याला बॅलन्स करण्यासाठी? W/2. तो कुठल्या डायरेक्शनने द्यावा लागेल? अपवर्ड डायरेक्शन का डाउनवर्ड डायरेक्शन? टोटल लोड W डाउनवर्ड आहे, बरोबर आहे. मग त्याच्यातला हाफला रेजिस्ट करतोय हा W/2. मग इकडे जो हाफ आहे तो आपल्याला अपवर्ड द्यावा लागेल ना. जर आपण अपवर्ड W/2 दिला तर हे W/2 प्लस W/2 म्हणजे टोटल W/3. आलं का लक्षात आता? हा डाऊनवर्ड डिरेक्शनला आहे, त्याला बॅलन्स करण्यासाठी अपवर्ड W/2 द्यावा लागेल. ठीक आहे. आता बघा हा जो काही W आहे, हा W बीमला अँटी क्लॉकवाईज मध्ये पुश करतोय. बघा इथं कुठलं रोटेशन येत आहे, अँटी क्लॉकवाईज. आणि हे पण काय करतंय तुमचं अँटी क्लॉकवाईज. म्हणजे शियर फोर्स काय असणार आहे तुमचा, शियर फोर्स ऍट C विच इज इक्वल टू
Negative.
शियर फोर्स ऍट C but after point load which is equal to minus W/2 kilonewton, minus W/2 kilonewton. Okay, so this is the shear force at C. After that, next we will move towards this B point. Again here 2 points are there, before reaction and after reaction. Okay, so next point we will consider D, shear force at B before RB. Before RB, that means without considering RB. Without considering RB. So without considering RB, I will draw figure here. This is our simply supported beam. Okay. So this is A point is there, RA, that is W/2. After that W is there. Okay. And we have taken section here without considering RB. Without considering RB. So for this W, only W/2 is balancing. So half force is remaining for this. म्हणजे ह्याला काय करायला लागते बघा, W आहे, टोटल फोर्स W येतोय, पण त्याच्यातला W/2च रेजिस्ट करतोय. म्हणजे त्याला अजून रेजिस्ट करण्यासाठी फोर्स किती पाहिजे तुम्हाला, W/2. W/2. अगेन हा काय करतोय तुमचा क्लॉकवाईज अँटी क्लॉकवाईज रोटेशन, आणि हे पण काय करतं अँटी क्लॉकवाईज रोटेशन. म्हणजे शियर फोर्स ऍट B बिफोर RB. शियर फोर्स ऍट B before RB which is equal to
minus W/2.
minus W/2 minus W/2 kilonewton. Minus W/2 kilonewton. W/2 kilonewton. And last point is remaining, shear force at B after RB. Shear force at B after RB. Last, shear force at B after RB. After RB. That means now whole beam we will consider. Whole beam. बघा आफ्टर B म्हणजे काय असणार आहे आपला हा ऍक्च्युअल बीम RA RB. So here W/2, here W/2, and here W force is applied. Okay, W force is applied. So this W/2 plus W/2 and this minus W. So W/2 plus W/2 is plus W and minus W, which is equal to 0 kilonewton. So shear force at B after RB, which is equal to 0 kilonewton. So these are the shear force calculations. Okay. Now we will move towards bending moment calculations. Okay. Please wait. I will take new whiteboard and then we will move towards. Yes, someone, Sharan Nagpur, has sent one message, LHS and RHS. Okay, no problem. Whatever notation you remember, you remember. I'm having no problem. Okay, so next step number 3 is bending moment calculation. Bending moment calculations. Bending moment calculations. Bending moment calculations. Okay. So I will draw figure here once again, so you will easily understand. This is A point, this is B point. I will give time for writing. Just you focus on this example. Here W/2 force is applied, and here also W/2 force is applied. This distance is L/2, this distance is L/2. This is C point, and here W load is applied. Okay. Now we will start movement from this B point. We will start movement from this B point. So you tell me, bending moment at B, which is equal to how much? Bending moment at B, which is equal to how much? We will calculate bending moment at B point. Suppose we have taken section at here. So bending moment at B, which is equal to
0.
W/2 into L, madam.
how it is possible? Because of force is applied at B point. Okay, their perpendicular distance is 0, na? So W/2 force is there, but perpendicular distance is 0. So bending moment at B, which is equal to 0 kilonewton meter. Okay. After that, next we will calculate bending moment at C. We will calculate bending moment at C point. Next point is bending moment at C. So second point, bending moment at C. Bending moment at C. For this, we'll consider this half figure. This is W/2. This distance is up to this L/2, and this is B point, and this is C point. Okay. So you observe this figure and tell me bending moment at C, which is equal to this W/2 pushes upward. That means nature is sagging, so it will be positive. So plus W/2 into perpendicular distance is how much? L/2. L/2. So bending moment at C, which is equal to WL/4 kilonewton meter. WL/4 kilonewton meter. After that, next we will calculate bending moment at A. Third point is bending moment at A. Bending moment at A. So for this whole figure, we have to consider here W applied. This distance is L/2. This distance is L/2. This is W. This is C point, A point, and B point. Okay. So we have taken section at A point, and we have to calculate movement at A point. So we will calculate from first this A side, and after that we will try right side. So from this left side, force is there, W/2, but perpendicular distance is 0. So bending moment at A, W/2 into 0, which is equal to 0 kilonewton meter. हे लेफ्ट साइड कडून येते. आता आपण राइट साइड कडून ट्राय करूया. आता आपण काय करूया, राइट साइड कडून ट्राय करूया. ठीक आहे. बघा हा W/2 जो आहे, हा W/2 काय करतोय, बीमला अपवर्ड पुश करतोय. बरोबर आहे. म्हणजे हा W/2 अपवर्ड पुश करतोय म्हणजे सॅगिंग असणार आहे. आपण याला ऑर लिहूया थोडं. ऑर W/2 इंटू परपेंडिक्युलर डिस्टन्स किती असणार आहे ह्या बी पॉइंट पासून ए पॉइंट पर्यंत? L. Okay. And this W pushes downward direction to this beam. That means hogging nature. Minus W into perpendicular distance is L/2. Okay, L/2. So WL/2 plus WL/2 and minus WL/2, which is equal to 0 kilonewton meter. That means we have to take algebraic sum of all the movement of all forces either from left side or right side. म्हणजे आपण लेफ्ट साइड कडून मूवमेंट फाइंड आउट केली तरी तीच व्हॅल्यू येणार आहे, किंवा राइट साइड कडून फाइंड आउट केली तरी व्हॅल्यू किती असणार आहे, तीच व्हॅल्यू असणार आहे. सो बेंडिंग मूवमेंट ऍट ए विच इज इक्वल टू 0 kilonewton meter. काही डाऊट आहे का ह्याच्यात कोणाला? So these are the bending moment calculations. Now we will draw shear force and bending moment diagrams. Shear force and bending moment diagram. So step number 4, shear force and bending moment diagram. SFD and BMD. SFD and BMD. Okay. So first we will draw given beam. So our given beam is simply supported beam and one central point load is applied. So we will apply here one central point load. Okay. Now we will extend these all lines for drawing shear force and bending moment diagrams. Okay. Okay. So whenever we will start draw shear force and bending moment diagram, at that time first we have to draw baseline. Okay, first we have to draw baseline. Please remember. First I will complete this figure and then we will move towards this. This is A point, this is B point. Here C point is there, W is applied. This distance is L by 2 and this distance is L by 2. Here RA is there and here RB is there. Okay. So whenever we will draw shear force and bending moment diagram, first we have to draw baseline. Okay. So first I will draw here baseline. So suppose this is our baseline. Okay. Now, if our force value, shear force value is positive, then we will draw above baseline. And if shear force value is negative, we will draw below baseline. So shear force calculations. Shear force at A, which is equal to how much? We will read here. Shear force at A point, which is equal to plus W by 2. Okay, shear force at A, which is equal to plus W by 2. That means it will go above baseline. Okay, suppose we consider here plus W by 2. After that, shear force at C before point load value is plus W by 2 as it is. Okay. After that, shear force at C after point load. After point load value is minus W by 2. That means sudden drop down is there. म्हणजे आता काय होणार आहे आपली या बेसलाइन पासून खाली minus W by 2 असणार आहे. Okay. And after that, shear force at B, shear force at B, but before reaction किती व्हॅल्यू आहे minus W by 2. ओके, तर हे काय असणार आहे तुमची इथं minus W by 2 as it is येईल minus W by 2. And after that, shear force at B point after RB व्हॅल्यू किती आहे 0. म्हणजे आपण इथं डायग्राम काय करू शकतो क्लोज करू शकतो. इथं 0 बिलॉंग होतं. ओके, नाउ वी विल connect this diagram. Okay, so above baseline diagram we will consider positive and below baseline we will consider negative. Okay. And we have to write values here. So shear force at here which is equal to how much? W by 2. Here also W by 2. Here minus W by 2. And here also minus W by 2. This is A point and this is B point. Okay. So this is the shear force diagram. Okay. This is the graph connecting various shear forces values in different locations. This is called as shear force diagram. Now we will draw bending moment diagram. Now we will draw bending moment diagram. Same here. First we have to draw baseline. Suppose this is our baseline. Now we will see bending moment at A, which is equal to how much? Bending moment at A.
0.
Bending moment at A here 0 kilonewton. Bending moment at B is 0. So this is B point. Bending moment is 0. And bending moment at C is WL by 4. So suppose we will mark here, and bending moment at C is WL divided by 4. And we will connect by straight line. Okay. Now this whole diagram is above baseline. So this whole bending moment diagram is in positive. And this is called as bending moment diagram. This is called as bending moment diagram. Okay. You observe here, L raised to power is 1. Okay. Or we have taken, suppose, I will explain why this inclined straight line is coming. This line is inclined straight line. Inclined straight line. Why this inclined straight line is coming, I will explain here. Suppose this is our B point, and here W by 2 load is applied, and we have taken section at X distance. We have taken section at X distance, and we have to find out movement at X. So this force pushes beam to upward direction. That means it creates positive movement. So plus W by 2 into perpendicular distance is X. So movement is W by 2 into X. Now you observe here X raised to power is 1. So if highest power of X or power of X, only power of X is 1, then inclined straight line will become. जर बघा X ची पॉवर ही 1 असेल तर त्यावेळी बेंडिंग मोमेंट डायग्रामचा शेप काय असणार आहे? इनक्लाइंड स्ट्रेट लाईन. त्यामुळे इथे आपण कशाने जॉईन केलेला आहे? इनक्लाइंड स्ट्रेट लाईन. जर X ची पॉवर 2 आली तर आपल्याला पॅराबोला ड्रॉ करावा लागतो. X ची पॉवर 3 आली तर क्यूबिक पॉलिनॉमियल. बट इन धिस question, X raised to power is 1. That's why the shape of bending moment diagram is inclined straight line. Now our problem is over. So please write down. I will give time for writing. Okay, write down. Let me know after your writing is over. So we will write some conclusive points. on this shear force and bending moment diagram. Writing of this slide is over.
No, ma'am.
Okay, let me know. So I will show next slide. Okay, write down fast. So we'll write some conclusive points. Depends on the shear force and bending moment diagram. एक मिनट. You're writing it over or not?
Yes.
Okay. So from this shear force diagram and bending moment diagrams, we have to write some conclusive points. Okay, can I rough this part? Can I erase these bending moment calculations?
Yes, ma'am.
Okay, so we will write here some conclusive points. Please write down next heading, conclusion between SFD and BMD. 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 First I will explain, then we will write. Conclusion between SFD and BMD. Okay. So first we will see for this simply supported beam and central point load is applied. Okay. So you observe here, if point load is applied at that time, shear force diagram connection is horizontal straight line. बघा जर पॉइंट लोड अप्लाय केलेला असेल तर शियर फोर्स डायग्राम आपल्याला कशी मिळते, हॉरिझॉन्टल स्ट्रेट लाईन मध्ये मिळते. ओके. अँड ऑल्सो यू रिमेंबर हियर द कनेक्शन बिटवीन टू लोड्स, कनेक्शन बिटवीन टू लोड्स रिमेन्स कॉन्स्टंट. म्हणजे बघा आर ए आणि डब्ल्यू ह्या दोन लोड मधलं कनेक्शन काय आहे आपलं, कॉन्स्टंट आहे. व्हॅल्यू चेंज झालेली आहे का, नाहीये. सो कनेक्शन बिटवीन टू लोड्स इज कॉन्स्टंट. As well as if in case of point load, the shear force diagram is horizontal straight line diagram. This is first conclusion. Then second conclusion. From this figure, maximum shear force is W by 2. So shear force which is equal to W by 2. But for simply supported beam with central point load. Simply supported beam with central point load. If simply supported beam given and central point load is acting at that time, shear force which is equal to W by 2. So these are two conclusions for shear force diagram. Now we will move towards this bending moment diagram. Okay. In case of point load, bending moment diagram connection is inclined straight line. बघा पॉइंट लोड अप्लाय केल्यानंतर बेंडिंग मोमेंट डायग्रामचं कनेक्शन कसं आहे आपलं, इन्क्लाइंड स्ट्रेट लाईन. व्हाय दिस इन्क्लाइंड स्ट्रेट लाईन कमिंग, बिकॉज ऑफ x raised to power is 1, that is our equation is linear equation. If equation is linear, at that time this inclined straight line will be there. So in case of point load, bending moment diagram connection is inclined straight line. And after that, fourth conclusion, maximum bending moment for simply supported beam with central point load which is equal to maximum bending moment for central point load in simply supported beam which is equal to WL by 4. And last fifth assumption is most important assumption. You observe here. Suppose this is point Y point. At Y point, which value is 0? And at that same point, which value is maximum? You observe these both figures and tell me. At this point, which value is 0 and which value is maximum?
Bending moment value is maximum and shear force value is 0.
Okay, good. So you have to remember here, if shear force is 0, at that point you will get maximum bending moment value. बघा C point ला shear force किती आहे आपला 0 आहे, पण त्याच C point ला bending moment ची व्हॅल्यू किती आहे maximum. So lifetime please remember, if shear force is 0, at that point you will get maximum bending moment value. So these are the conclusions from this shear force and bending moment diagram. Now we will write one by one. I request all of you, please write down fast. So our first conclusion, in case of point load, 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 SFD, shear force diagram connection, connects by horizontal straight line, horizontal straight line, horizontal straight line, horizontal straight line. Full stop. Also, you have to remember shear force remains constant. Shear force remains constant. Remains constant between two loads. Between two loads. So this is first conclusion. After that, second conclusion related to shear force. Maximum shear force which is equal to W by 2 in case of simply supported beam with central point load. That means if simply supported beam is given and central point load is acting, at that time maximum shear force which is equal to W by 2. After that, we will write third conclusion from this bending moment diagram. In case of point load, connection between two bending moment values is which type of connection? Inclined straight line. And after that, next fourth conclusion from this bending moment diagram is maximum bending moment which is equal to WL divided by 4. Same here, simply supported beam with central point load. And last assumption, that is most important assumption related to relation between shear force and bending moment. If shear force is zero, at that point, bending moment is maximum. So that much conclusions from this shear force and bending moment diagram. Okay. Write down fast. I will take 10 minutes. Let me know after your writing is over. Okay, your writing is over or you want time? Yes?
Over.
Okay. So today we will stop here. In next lecture, we will solve numerical on simply supported beam, but uniformly distributed load, uniformly varying and movement couple is applied. So today we will stop here. Thank you for attending lecture.